Hello, everyone, and welcome to this product demonstration webinar, Speed Up Your Quality Process, brought to you by HiQA and S4 Metro. I am Lisa Sterling, your host and moderator for today's session. Before we get started, I would like to mention just a couple of housekeeping items. We invite you to ask questions throughout the presentation by typing into your Q&A tab at the bottom of your screen, as your phone is muted. We will address the questions received at the end of the presentation. Please note that this webinar is being recorded and will be available for playback in a few days. I would now like to introduce you to our presenters, Luis Lopez from S4 Metro and Hans Dirks from HiQA. And with that, I will turn the floor over to Luis to get us started.
Hello, thank you everybody for being with us today. We are Solutions for Metrology. Many of you might already know us. And we bring you IQA because we like to add value together as a company. So we began this journey of metrology and quality assurance 14 years ago. We have 23 employees right now in 3 geographical locations that develop 5 business areas that we'll talk about a little bit. And we are here to support you as close as possible. So these are our main 5 activities, or at least it was. Now we have a 6th one. So we have metrology, training, engineering, equipments, and maintenance. And right now we added IQA to the quality assurance theme. So this is what we offer to support you on a regular basis. So scanners, computed tomography, CMMs, arms, quality assurance software now, and quality dimensional software, also reverse engineering, but these are the tools that you already know. Today we have something new. So what is IQA? First of all, it's a QMS solution integrated in your tools, ERP, data acquisition, and one platform, all of your quality. So why do we care about IQA? It was our missing piece of integration in the company, the link with all the business areas. What I mean is can link production, buying department, metrology, maintenance, all in one, okay? And this is the next step, aiding our clients, basically. So our mission is quite clarified for us, and it's to bring quality to our organizations that work with us. And why do we think you should care? Well, you want to spend less time in paperwork, less folders, less dependent on operator. Eliminating paper, it's even a concern in terms of ecology, security, database, and most of all, no errors in quality. We know how much those cost. And so we need something that auto-collects data, that it's easy to search, and that can do real-time analysis. So we spend less time collecting data and more time just analyzing data. And we integrate everything with our ERP, accountant, sales, engineering, production, and metrology. So this is a software that can bring all of this together. And this is what we're here to present you. I pass to my colleague, Hans.
Okay, thank you very much, Luis. Thank you for this great introduction. Welcome all to this webinar from the Netherlands, our HiQA headquarters serving all of our European customers and partners. IQA head office is in New Jersey, USA, and from there we work with partners all over the world to be able to use our software in any country, any region, and also supported by local partners in their own language, like S4 Metro in Portugal. And as I said, from the Netherlands, in the European office, we serve our partners and customers in Europe. We can do that in several languages, but unfortunately not in Portuguese. So that's why we are very happy with our partnership with S4 Metro, with Luis and his team. As Louis already introduced, we are a quality management software, and actually only for the manufacturing business, speeding up their quality process and make your job many times faster, especially, of course, where it starts with auto ballooning, being from a 2D drawing or reading a 3D part, 3D CAD part with PMI. And when you use it to the full, you can even speed up your process, your total quality process, with data collection, data analysis with up to 75%. These are comments from our customers, experience from our customers that make full use of our quality management system. And that enables you to create reports and submission packages in minutes rather than hours or even days. As of now, we have 1,300 plus customers in 5 continents, over 20,000 users worldwide. And of course, we take very great care of your data security, and we have a collaboration mindset with all other systems out there, naming ERP systems, PLM systems, MES, whatever you have in your digital landscape. We are happy to integrate with those systems to create your Industry 4.0 solution. That's important for you, therefore it's important for us. And that is to state that we are a real customer-driven culture. We are from manufacturing, we understand manufacturing, and can work with manufacturers on their quality process. So reimagine your quality management system with HiQA 360. It's an all-in-one solution with a database-driven solution, a centralized database for quality planning, planning, inspection, reporting, of course, so you can have your parts on time, on quality, and on budget for your customers. All-in-one database-driven solution, as said, over on the left side, you see how we view the quality process at manufacturers with several parts like preparation in part and job planning part, production and data collection. So this is where you really produce your part and we will collect the data. During the demo, I'll show you more and I'll tell you more about this. And at the end, of course, using that data that was collected in that centralized database, using that for reporting, analytics, and submission packages. And it can even connect you with your suppliers or with your OEM if you are a supplier, where you will talk on one platform, a secure platform. You are connected and all data is shared that you want to share. And you even have your quality data from your supplier earlier than you have your part. So now we'll switch to the actual demo. And let me check. I'll open up the application and start from a 2D drawing. And I'll select a drawing, 2D drawing that can be used, any type of 2D drawing, of course, in TIFF or in PDF. And this is a drawing that I once got from a customer that I'm allowed to use. And this is a drawing that consists of actually 2 pages. As you can see, several dimensions, GD&Ts, or some information in the title block, not all, because the customer deleted some information that was confidential. It even has a second page with some notes on it that we can also, of course, capture from the drawing. Let's go back to page number 1 and handle it in this page. And first, we will grab some information from the drawing, from the title block, that we can use to fill out, just to prevent me from using my keyboard, because as soon as I use my keyboard, then I'm able to make mistakes. I just grabbed this information and turned it into the part number. Just as an example, of course, this can be my part name. And we can also grab the revision number. Well, revision number is already revision A, so you wouldn't see anything being changed, but that's all okay. Then the units. Over here we have the units in metric or in English. Most of the participants are in Europe, so you'll be working metric. But if you would receive an inch drawing from your customer, then you can just balloon it and handle it in inches. And then using this button over here to convert it from metric, from inches to metric, so you can work metric internally because all your employees are educated in metric, no metric, and also your measuring equipment will be calibrated in metric. You can work internally in metric and then at the end convert it to inches when you produce a report for your customer. So your customer will receive the quality report in inches again. Okay, so we filled out those part properties using the information from the drawing. The same I can do for the material. There's also material indication on this title block, so let's also use that one. And the system will create a record for this material to be used for this part. And of course, you can enter more information. I'll just type in some nonsense using my keyboard. So at the end, you can see where this came from, like certificate number, whatever information you want to save with this part. Perhaps the supplier of the material you want to keep. So we'll save this and we can even add like a material certificate. So I'll upload a file. And I just grabbed a example material certificate from the internet. And let's open this one up. And now you see this material certificate is uploaded to my part and is stored in the database. And that's very important. So we are grabbing information from the drawing, but also information that's not on the drawing, but should be part of the data in our database. Everything is stored in that centralized database. Something before we want to start ballooning this drawing is that I also want to add like tolerances to the dimensions that don't have a tolerance on the drawing. Of course, when there is a tolerance, that tolerance will be read and applied for that dimension. And the dimensions without a tolerance will get a tolerance according to these this tolerance tab settings. So let's go over there. And as we are working in the metric environment, you'll probably also use the range table, the DIN ISO 2768. Of course, there are possibilities to use other tolerance tables. I have some for plastic parts in here and other tolerance tables. That will be applied for this part at this moment. I also want to apply the ISO 286-2 or the ISO hole and shaft tolerance table for this part. And let's save those settings for this part and return to my part properties. With that said, we can start ballooning, and that's only one touch of a button. So let's balloon this one and let's keep it to the current page and let's balloon everything. Okay, that process is started. First thing the system does is calibrating the drawing. So it'll recognize the frame of the drawing. It will recognize the the title block on the drawing and search for the most used font on this drawing. And with that font, our OCR engine, optical character recognition, will identify single numbers, letters, characters, what's on the drawing. And in the last phase where the system is working now, it'll be combined to dimensions. So the system also has knowledge, call it AI, how this single characters can be combined to be a dimension according to the standards. And within, let's see, within 46 seconds, the system recognized 145 dimensions on this drawing, and that's only on sheet 1. Remember, I only ballooned sheet 1 is this case to save some time. I think when you do that by hand, it'll take you a little bit more time. We see our customers using pen and paper or Excel for that matter. Well, that's only digital paper for this purpose, and it can take them hours to balloon a drawing like this correctly. And also that last remark, correctly, is quite important. Let me explain a little bit more using the example of one dimension how the system works. So it'll recognize pixels and pixels that are connected. And these pixels are connected, and with this picture, this will be compared to the pictures in the font that was calibrated, and from that moment on, the system will know that this is the number 8. And it'll search to the left and to the right and to the top and to the bottom for other characters that can belong to the same dimension. And in this case, the system found a 4, a 1, a comma, a 0, and an 8. And the shape is showing us how far the system searched for characters that could belong to this dimension. On the right side, the system is showing us in the viewer what it found. So this should be the same as we see on the drawing. And down here, it is showing in parameters. So in this case, it's a linear dimension. It got the tolerance from the general tolerance table. Nominal value is 148.08. And these are the tolerances from that tolerance table. Well, let's look at a dimension that is a little bit more interesting, like this dimension number 18 that got balloon number 18. Actually, it's not one dimension, it's a group of dimensions. We see 5 sub-characteristics. We see it in the viewer, like a diameter, also a depth dimension, the thread, in this case a metric thread, the depth of the thread, and a true position for this threaded hole. On the left side, in our bill of characteristics, what you can consider as what's in our database, you see the same. And you see this number 18 with 18, 1, 2, 3, 4, and 5, all split out in that bill of characteristics. All 5 of them are in here. And you see much information as the nominal, upper tolerance, lower tolerance, the units, everything. There is even much more. So there is much more information in our database than what you see at the first glance. And of course, you can determine what column you want to see and in what shape and form you want to see this. Another thing that comes to mind when you see this group of dimensions is that 2 times that you see on the drawing over here. Of course, we know that means that there is another instance of this threaded hole somewhere in the product. And if you have to do a first article inspection, and usually that means that you will have to inspect all dimensions, so 100% inspection, then you would also need to inspect those dimensions on the second instance of this threaded hole. And for full traceability and also to avoid any misunderstandings and interpretation, we can also multiply this group of dimensions. And you can use this, you don't have to use this, but this gives you more clarity on what is expected. So you see, we recognize that 2 times, that's on the drawing over here. It's recognized in our multiplier, and it's also here in our multiplier column in our bill of characteristics. So we already expect 2 results for each dimension because we have 2 instances. Let's make it even clearer by using this multiply button, just to give you an idea how detailed that we can define those dimensions in the inspection plan. In my settings, I'm generating 2 extra balloon numbers, 18_1 and 18_2. and I will take them to the instance that I find is 1 and 2. Of course, it's not important which one is 1 and which one is 2. It's to distinguish between these two groups of dimensions. So anyone measuring on this threaded hole, the data is found in the group 18_2. This one, of course, 18_1. And below here in our bill of characteristics, we now see two groups of dimensions, 18.1 through 5_1 and 18.1 through 5_2. That's quite important to distinguish and to make sure there's no room for extra interpretation, because interpretation can mean errors. Okay, that's on ballooning. One very important point to be checked at this point is that some drawings that you get from your customers can have some funny stuff in it, and perhaps not all according to standard, but you still want to balloon all dimensions. You can check visually if everything was ballooned, but we created a tool to recognize if the system missed a dimension, and that can happen. It is OCR, and with this button we can white out all dimensions that were recognized, and the dimensions that were not recognized automatically will appear, and we see 3 of them over here. That's not bad, that's okay. Let's see how we can balloon those by hand, assisting the system to recognize them. This one is in a different font, so that's why it's not recognized. Perhaps it's done by the engineer on purpose to fit in this area. I don't know, but I have to deal with it. So I can just draw my shape around this dimension, telling the system to recognize a dimension in this shape. And with this, the system will vary a little bit on the size of the font and then find the dimension. And also, of course, add the tolerance to it from the tolerance table. Over here, we see a basic dimension or theoretical dimension, as it's also called. And I think you can imagine why the OCR wasn't able to recognize it, because the arrow is touching the 8. It's also crossing the rectangle of the basic dimension. Dimension lines are crossing, so it's a mess of pixels. And let's see if the system can recognize what's in this box, if a dimension can be recognized. Well, this is pretty impossible to recognize. So let's assist. I'll tell the system it's a linear dimension. And in this viewer, you will see the dimension appear as soon as I define using the parameters. Nominal value is 8. And the tolerance, well, normally you would never even balloon a basic dimension. You would also not measure it. But I promised to balloon all of it. So let me also add a tolerance. Basic dimensions don't have a tolerance, so in my settings, I give them a tolerance of plus 999 and minus 999. Let's also make it 100% clear and also balloon this one. And in this case, the system shows us what it would recognize, and that's what's in the viewer here. Well, that's not a real dimension, so that's why the system did not put it in our bill of characteristics. Now I forced it to, and it didn't do it because this line touches the 9, this one touches the minus sign. So this is what's left, and that's not a normal dimension. Let's assist a bit. So this is a tolerance dimension on the drawing. Nominal value is 0.90. Upper tolerance is 0. Lower tolerance is minus 0.1. This can be deleted, store it, and we are good to go. Okay, so now we know that it's fully ballooned and all dimensions are here. Our ballooning is numbered from top to bottom, from left to right. So it's scanning like this on the drawing, and the next dimension will get the next number. The dimensions that I assisted on ballooning are 91 and 92 and 93. They are on the bottom of my bill of characteristics over here, and I want to have them in line with the other numbering. Until I published anything in a drawing or an inspection plan, I can of course renumber the ballooning on this drawing, and now it's renumbered, and now you see that it's 39, 40, so it's in line with the rest of the dimensions. Okay, that's the ballooning part of our system. Let's talk about the work preparation part. So we are preparing for production, and we can add parameters to any dimension in the bill of characteristics. And I want to talk about, for instance, the gauge category to use. And the gauge category means it should be measured by a coordinate measuring machine or by a vernier caliper or whatever, not a specific caliper with a serial number, but the category. And we manage all the gauges that you use in the gauge management system. And that gauge management system has all your gauges in it. Reason why you should do it in our gauge management system is that we can store which gauge was used, and then that gauge is also connected to each dimension that it was used for. In the gauge management system, we have calibration details, as you can see over here. So for each gauge, we have that calibration detail, so we can prove, and you can prove, that this gauge was calibrated at the time it was used. To go even a step further, whenever a gauge is not calibrated or when it's broken, then we can take it out, and then we won't accept information, results data from that broken gauge. And that's also to make sure that you don't use broken or non-calibrated gauges. We even have a usage history, as you can see over here. So we can also take it from a view of the gauge, at which dimensions am I used or was I used. So each dimension is connected to the gauge, and the gauge is connected to that dimension of each sample that you take for each part. So whenever a gauge cannot be calibrated anymore, you can search for the dimensions on the parts that it was used for and check it with another gauge, just to be 100% sure. So you have full traceability also on gauges that are used. That'll help you also when you have to be certified and somebody comes to check on how you store your data. Well, you can use our quality management system to show how you work with that data, and our customers tell us that they benefit from it also in doing an audit in a day or half a day instead of 3 days. That could be also of importance to you. So gauge category. Next is a designator. So each dimension can have a designator. And for instance, that can be a critical dimension. Let me give you a quick example. And of course, critical dimensions should be measured more often. So it can also influence your sampling rule that we see over here. Quick example, let me filter on for instance, diameter dimensions, and let's select them all, and let's do a bulk update on these dimensions. You see that the dimensions on the drawing and in the bill of characteristics are connected, so I can do any choice and any selection, use a box select or individual select or whatever. So I want to make sure that these are all assigned critical, so they have a designator critical, and I want to use a vernier caliper to measure it. Apply and close. So that's easy to add information to dimensions and to filter and select on the bill of characteristics. Okay, let's go back to all dimensions again. And now you see some of them are critical. And we already talked a little bit about sampling rule. What sampling rule means, how often should this dimension be measured? In this demo settings, I'm using an AQL-based sampling rule. That means whenever the AQL table tells me that a sample should be taken, this dimension should be measured. Some other dimensions have a setting 10%, and those are dimensions that have to be measured with a go no-go gauge, or I should view if it's okay and say it's pass or fail. So pass-fail dimensions in my demo settings are have a sampling rule of 10%, and this will indicate that there will be a different number of dimensions that should be measured for the samples in the job that I'm performing now. One other thing I want to tell you before we move to data collection, and that is on manufacturing operations. We are capable of grouping dimensions in a manufacturing operations, meaning the steps for this part to be produced. And of course, that first step is cutting the raw material for this part. So let's define that manufacturing operation. We do have a finished part manufacturing operation, which means all dimensions on the drawing are, of course, finished dimensions, and they are therefore part of that finished part manufacturing operation. Let's select 3 dimensions just to demonstrate the first step, length, width, and thickness of the block of material that should be cut. So let's add that to an operation. And the system will create an operation 10, and these 3 dimensions will be part of that operation 10. I'll look into the details, pushing the pencil button over here, and let's name it raw material cutting. You can name it anything you want. When you go even further, we won't cover that today, but when you go even further to the PQP, process quality planning module, where you can create different documents and workflows for your process, then you can even tie it to a process. That'll be part of another webinar that we'll do for you, or for a personal demonstration that we can do for your company and your colleagues. So I named it raw material cutting, and now I have this available in my manufacturing operations to view it. And when I view this, I only see the 3 dimensions of this first operation, and also the 3 dimensions in my bill of characteristics. But of course, these are the finished dimensions and not the dimensions that the person responsible for this manufacturing operation should check it against. So let's also do some changes over here. I'll select all these dimensions and do another bulk update. And let's say we will add like 4 millimeters to the nominal value, and we will set the tolerance to +1 and -1, just as an example. Applying close. So now for this process, we have changed the nominal value and the tolerances, so the person responsible for this step doesn't have to calculate, think, whatever, just measure, and it'll be compared to these values. So you can prepare it properly for your colleagues on the shop floor. Okay, let's go back to the finished part and go back to my part properties. So look at the original drawing. And of course, from here, you can create a new ballooned drawing. So let's show you, balloon it on the current page. And this will create a PDF with bookmarks. And you can use this as a digital drawing on the shop floor, or for the people that have to program your CMM, because they should use the same balloon numbers to name these dimensions. So later on, we can capture the results from that CMM and store it with the dimension of that sample in the database. So with bookmarks, as said, that'll lead you to the right dimension on the drawing. I don't have to save it. It's saved automatically, and that's in our Files tab over here. So everything that I do, you only saw me touch that Save button over here. When I made changes in the parameters over here, then I should save it. For the rest, the system will save everything that I do in the database. Nothing will be lost. Next to that balloon drawing, of course, I can also produce an inspection plan. And that's probably how you are working now when you would do it manually. And this template will grab the data from our database for our finished part and put it in a report, in this case, an Excel report. And we made an example of an inspection plan that can be used, but you can also create your own inspection plans in your own layout and color and font, whatever you want. We have a report designer for you where you can use this and create your own reports. This can also look like the report that your customer wants to receive from you. So this is the report that if you want to work manually on the shop floor, your colleagues can fill it out, or your supplier can fill it out if you're not really connected to your supplier. So send them the balloon drawing, send them the Excel file, have them fill out this document, and we can import it. I will also use this for the demo purpose in showing you how we can import that data by taking this nominal value and put it in the actual column like this. So now I have mimicked a result file that can come from your supplier or even from your measurement machine. It will not be in this format, of course. We have the ability to read any format from any machine, being CMM, VMM, whatever machine, whatever software you are using. And I will store this to be used for my demonstration how to import results from such a machine. And I'll put it on my desktop. Let's see over here, and I'll use, let's see, I'll put my own name in here and store it like that. Okay. This is not be used anymore. So now we have created a balloon drawing, prepared everything with the gauge categories, sampling mode. So we are ready to create the job in our database. This job creation can also come automatically using our connector from your ERP system, because all this information that I'm entering now can also come from your ERP system. And we can create that connector to any ERP system using our API, our application program interface. So let's say we have to produce 20 parts, and the system will now in a database prepare the hierarchy for this part. So we started with a part, and a part can have a revision. The system, by the way, will assist you in handling that revision. So you only have to attend to the changes that have been done. You don't have to start all over again when you get a revision of the part. Only the dimensions that have changed in the old and the new revision. We can go in detail for that when we do a personal demo for you, and I can show you. So the job is created. So the hierarchy in our database is we have a part with a revision, then we have our job. Each job can have a lot, and I'll make that lot active as well, so we can collect results later on. If it's in planning, the people on the shop floor can't see it and can't enter results, of course. Then for each job, we can have samples, and let's have the system create those samples automatically from the AQL table that I mentioned before in that lot one that was just created. The system will use that AQL table and with these my default settings, and came to 3 samples. So 3 samples will be created in the database, and those are placeholders for all the results that can come in from the shop floor, from people that are using manual gauges, and it can come in, of course, from measurement machine, or perhaps when you outsourced it to a supplier, you can also get data from your supplier, and that data, the result data, will also be stored in our database, and all will be connected. So at the end, we'll have for each dimension, we know who measured it, where it was measured, when it was measured, using what tool, and of course, what result. So these are our 3 serial numbers that we have to measure. And as predicted with different numbers, because we have some parts that have dimensions that have to be measured 10%, and this is a few less. Let's go back to the drawing and look at our samples now. So now we also have the samples in here. And of course, you will never view this live, how the results flow in. But I'll show you today just to make sure and to show you how it works. When we look at sample number 1, we see that everything is gray. Nothing has been measured yet. We have our placeholder in the database, but no actuals, no results. The system switched to the result editor. So over here, we could enter results. But let's first show on this sample number 1 how we can import results from a CMM or VMM or whatever machine. So we will import those results. And by the way, this can also be automated. And let's see on my desktop where it is. There, I named it Hans. Okay, let's open it up. So this can also be automated, what I'm showing you now, using our machine sync. And a machine sync meaning the machine, the CMM machine, will output its results in a certain file format. And we will be searching for that file in a folder where it drops it. And we will automatically connect the results to the right serial number of that part, importing all the data, storing it at each dimension of each sample of that part in our database, ready for analytics or reporting. So it gave me a preview of that file with the results. Well, I just copied it over, nominal to actual. So most of it will be okay. Most of it will be intolerance. And the system will show me in a few seconds visually the results on the part drawing for this sample number where we imported the results from a machine. And as predicted, most of it will be green, meaning it's measured and it's within tolerance. We see one red dimension, and red meaning it's out of tolerance, but that's normal because it was a minus tolerance, and nominal then of course is out of tolerance. We can also add dimensions or results in the main application where we are looking now. Let's do that in sample number 7, so the second sample. And I want to show you manual entrance of results. In the main application, which you are viewing now, I can add results like this and use the actual over here to type in my result, 148.18, store it, and that's okay, that's green, within tolerance, so move on to the next dimension. Of course, we can also have gauges to check it, and then it's not a value, but then it's like pass fail. So let's make this pass and store it, and that's also green. So it is possible to add results also in the main application. For the shop floor people or incoming goods or whatever, you can also use our data collection application, which is a browser application which is running on your server, and anyone that is that can browse on your network can use that application. Let's see, some difficulties finding my desktop. Let's see. Yeah, there it is. So this is my application for data collection on the shop floor, and I'll log in. I was logged in before, but it kicked me out because I'm not using it for some minutes. So the system will free it for anybody else to use. And I'm running it on a server now. And this is an application that is meant to be used on, or that can be used on a touchscreen tablet. But of course, you can also use it on a multitasking screen or computer or laptop or whatever. People on the shop floor can find the part that they are working on using the QR code or barcode to scan it and identify the sample that they are working on. We can also find it by part number, job number, whatever. Or, for instance, using a gallery search. Gallery search meaning that I can scroll through these drawings and use these drawings to select the part that I'm working on and that I want to do my measurement on. And over here, we see we now stepped into our job, and we see our job number with the 3 samples, with a dashboard, what has been done with the job information on the right side. I'll step into this job and we'll see that it jumps over the lot because I only have 1 lot. So I can directly go to my samples, and I have 3 samples. The first sample, you see a lot of dimensions are already measured. So I already have 120 results. But on sample 2 with serial number 7, I only measured 2. So let's jump into this one and continue measuring. And here you'll see the same view as you see in our main application. This is the main application where we prepare things and we can view our samples. And this is our data collection application, the browser application running on your server. And over here, you see that 2 dimensions already measured. It asks me to measure dimension number 12308, dimension number 2, with a nominal value of 12308 with the tolerance. Over here, it's asking for the result. I can use my touch screen. I can use my keyboard. I can even use a Bluetooth caliper to measure this dimension. And let's just use this one to type it in. So this is the view that your people on the shop floor will have using this application to measure dimensions. I can also use this one, and I'll try to use my Bluetooth caliper, although during the demonstration this morning that I did for a customer in Germany, I think my battery was low, so I hope it's okay enough to connect with Bluetooth. So I'm not sure if you can view, because I think I'm only in a very small window in this webinar, but this is my Bluetooth caliper. And I can use it to measure this dimension. And let's just measure this one, and I will show you that this can be used to measure. So I'm not typing anything. Let's do it like this. I'm just pushing the button, and it'll collect the result and store the result in the database at this dimension. So you can use any Bluetooth connected device to capture results. Let's go back to the main application and let's look at this one. Let me just refresh my screen so we can see that this was also measured and showing the same results as on the data collection app. Last step is to produce a report, and let's go back to sample number 1 because there are more results over here. So there's more to see when I produce a report. So inspection report, single piece report. In this case, you can also, of course, have a multi-piece report. In this example, I'll use a template for an aviation standard report 9102 revision B. I think there's already a revision C, but just an example. And let's create that report for, in this case, sample number 1, because that one is active for this particular part. The system is now extracting all the data that was collected for this sample number 1 from the database and will show me in that report. And on form number 1 of this report, we will have part information. On form number 2, we will have the material information, process information, and here you see the nonsense that I typed in the beginning. For number 3, of course, my results, and no deviation, of course, because I just copied the actual the nominal to the actual, so that's showing the results. And this form also requires attachments, and that's a material certificate that I entered before, and also my ballooned drawing. With that, I think, well, I just need to mention that I don't have to save that report because that's also saved in our database for you to review. So you saw that I created an inspection plan before. Now I also created an inspection report that you can always enter using the database entry for those samples. I think this brings us to the end of the webinar, where we want to address your questions. Lisa, I'm not sure if you have any questions from the viewers.
So let's take a look. Thank you, Hans, for that. As Hans mentioned, now is the time that you can go ahead and type into your Q&A, which you will find at the bottom of your screen there, or you can use the chat if you prefer. Okay, let's look. We did have a couple of questions come in throughout the session, so let's get started.
Nice.
The first one says, where are you getting all of the tolerances from?
Yeah, good question. Well, the tolerance, of course, come from the drawing first. So whenever a dimension has tolerances on the drawing, we will use those tolerances. But when there are dimensions without tolerance, they will be drawn from the tolerance table that I have defined in my part properties. So in this case, it'll come from the DIN ISO 2768 tolerance table, which is in our tolerance table area, which you see over here. And this is my example of the linear dimensions in this DIN ISO 2768 with the actual tolerance values here according to this quality level.
Okay, great. Here is the next question. It says, we currently manage gauges in Excel. Do we have to enter all of our gauges into HiQA manually?
That's a typical question we get, because when potential customers see how we do our gauge management, and that we have all the data stored connected, which is the most important aspect of this, to all the parts and the dimensions and everything, they all want to start using this gauge management system instead of, well, sometimes it's Excel, sometimes it's a system that is homegrown or whatever. And the answer is yes. Of course, you can reuse that data. It also gives you a moment to review the data that you already have and perhaps kick out the data that that you don't want to save anymore. But if you are able in your old system to create a CSV file from that system, then we can import those. And we don't care in which format that your CSV file is. We can make a connection between the data in your CSV file and import everything, including history, at one point, and then you can start managing your gauges from our system. And of course, data that you didn't have before, you can enter for new calipers or add for your calipers, like, for instance, a picture or whatever. Good questions.
Perfect. Very nice. Okay, here's another one. It says, we make custom operation drawings. How would we handle that?
That's an even better question. Custom operation drawings means that you would have like a drawing for manufacturing operations. And you saw that when I created my manufacturing operation raw material cutting, you see that I'm still using my finished drawing, but I highlight the dimensions that are part of this manufacturing operation. And over here, you see them also listed. Many of our customers who were used to creating separate drawings for each manufacturing operation, and also perhaps inspection plans for each step. They can still use this if they want to, because you can create a balloon drawing for this step as well, explaining your people on the shop floor or wherever they have to check it, give them the information they need. So this is a simplified ballooned drawing only for this manufacturing operation. And you can also create that list of an inspection plan only for this manufacturing operation. So you can do this and even make it manual or even on paper if you want. But our goal is to be more digital and paperless. Perhaps first less paper and then paperless. But that is the ultimate goal. So you could eliminate all of this and just use it digital. If you do want to use a specific drawing for a certain manufacturing operation, for what reason, then you could add a manufacturing operation drawing to this manufacturing operation. So you can even make it and then replace this drawing by that manufacturing operation drawing. So you can still give that information to your people on the shop floor if they really need it. Good questions.
Excellent. Okay, so we are just about at the top of the hour, so let's conclude with this final question here. It says, how long does it take to be trained on the HiQA software?
Of course, it depends on what package that you choose, what configuration that you choose. But let me tell you that to do this, what I did for you today, and especially the ballooning, you can do that yourself after 2 hours of basic training. So it's very intuitive, it's very simple to use, and we have our HiQA Academy, where you can even train yourself online in your pace, in your time, whenever you want to do this. And after that, you will be able to do this ballooning and data collection yourself. If you want to take it a step further with data collection, with reporting and stuff, I would say at least like 8 hours of training, which will be blocks of 2 hours when you do online training. And then we'll have a personal training for you, like a basic training, Q&A session, advanced training, another Q&A session. And meanwhile, we will integrate your CMM, your gauges, and other machines that should be integrated, perhaps even create a connection to your ERP, PLM, MES system. And then after a few months, the whole configuration should be working and serving you for your quality process.
Okay, great. Well, thank you so much, Hans, and also Louis. At this time, Hans, if you can put up that final PowerPoint slide, we'll go ahead and put our contact information up on the screen so that you have it handy. However, as I mentioned at the beginning, we will be sending out the recording in the next couple of days if you'd like to share it with your colleagues or watch the playback at your leisure. And also feel free to reach out to us with any additional questions that may come to mind. We are happy to take time with you on a one-on-one basis, work with your parts, your data, and show you everything. So here's the information. At this time, we will conclude the session. Thank you all so much for spending the hour with us. Have a great day.
Thank you very much.
Thank you, everybody.